All right, today we're going to take a little closer look at arithmetic series. Same rules apply when we're talking about, we're going to look at arithmetic sequences. Same rules apply when we're looking at arithmetic series, except that those are already added together in a sequence. It's separated by a comma. Geometric sequence, infinite geometric sum. We'll talk about the restrictions on that, and how to identify a quadratic sequence. You're not necessarily going to be asked to directly find certain values and summations in that regard. You're just going to be asked to identify if it is a quadratic. So let's take a look at this. If we're talking about arithmetic, this is the formula for finding a certain term. So A being a certain term at this placeholder. That's what the n stands for. So if we look at 8, that's the third number in our sequence. So n then is 3. So what is the value of the term at 3? That's how we would read that. A1 then would be the first value, which would be 2, and D is the common difference. When we find the common difference, we take the difference between two values, so the a to the n minus a to the n minus 1. So that's kind of an overly complex way of just saying take the number minus the number before it. So 5 minus 2 is 3, and to be sure that this is arithmetic, we have to do it twice, just in case it was a geometric that looked like an arithmetic at first glance. 8 minus 5 is also 3. So I found that our common difference is, in fact, 3. If we wanted to say find the sixth term, and yes, of course, we could just add 3 to that 14 and find it by brute force. But let's see what we get if we actually plug it into our formula. So a to the sixth, so we're looking for the sixth term in this sequence, is equal to the first value, a1, plus, and we are looking for the sixth term, n minus 1, times the common difference of 3. So sixth term in our sequence, we only have the first 5 listed. 2 is the initial value. Again, that n and that n will be the same. It'll be 6 minus 1 times the common difference. And we find that that is 2 plus 6 minus 1 is 5, times 3 is 15. That equals 17. And again, as I said earlier, we could have just added 3 onto the end to 14, and we would have found it that way as well. But just to demonstrate how this one works, because they may ask you something like, what's the 30th term? And then that can be very tedious to plug all those values in. So given now that we have A6 is equal to 17, let's just put that aside for a second. I can erase these values as well. So we know that the common difference is equal to 3. So what about the summation? So if they're asking you for the sum of the first 6 terms, then we would plug in the summation for 6. That n and that n are going to be the same as before. So 6 over 2. Our initial value is not changed. That's a 2. And we're going to add our a to the n. So what you may have noticed here is that for us to find the summation, we need to find the value of an first. So you may be asked to find the summation. Know that you may have to do this formula first to get that term before you can proceed. We already have a6 from before is equal to 17. So we can just plug it in. That will be 19 times 6. Let's see what that ends up being. 19 times 6 is 114. Divided by 2 is 57. So if we add the first 6 terms, we should get 57. Again, we could kind of brute force this to make sure that our math is correct. So 2 plus 5 plus 8 plus 11 plus 14 plus 17 does give us 57. And again, in a problem like that, we could brute force it, but they may ask you to give me the sum of the first, 80 terms, and then that will be much more difficult. And that will take care of what you need to do with arithmetic. Let's move on to geometric. So geometric, just like we found the common difference, now we need to find the common ratio. The common ratio is a to the an, all over an minus 1. And again, this is just a fancy way of saying take the term divided by the term before it. If we do this, 4 divided by 2 is 2. And just like we had to check for if it was a geometric sequence when we were doing arithmetic, we need to check this geometric sequence and make sure it's non-arithmetic. So 8 divided by 4 is also 2. So we see that it actually is a geometric sequence. So now that we have R, we have the first 5 terms. Let's do this again for the 6th term. Again, we could brute force it, but let's see if our formula works. A to the 6 is equal to the first term, which is 2, times R, which we found to be 2, to the n minus 1. 6 minus 1 is 5. So, if we were to do that, we would get 32 times 2 should be 64. Let's check our work, and we find that is true. If we just multiplied 32 by 2, we'd also get 64. What you're going to notice here is that when we talk about summations then, we don't have to find an first like we do with arithmetic sequences, so don't waste your time in that regard. If you're asked for the summation, we can go straight to it. So we're going to erase this. And our common ratio obviously stays the same. So if we're trying to find the summation of the first 6 terms, that's going to equal the first term multiplied by 1 minus r, which we found to be 2, to the nth power, 6, right? 6 there and 6 here. And then 1 minus r. So, if we work this out, we are going to get 2 times, in parentheses, 1 minus, that looks to be 64, over negative 1. That one to being 2 times negative 63 over negative 1. 2 times 63, which will equal 126. So what we found here is the summation of the first 6 terms should equal 126. Let's see if we brute force that if we get the same thing. Remember that our 6th term was 64. So 2 plus 4 plus 8 plus 16 plus 32 plus 64 does in fact equal 126. Just like before, the reason we're using such small sequences is to demonstrate checking our answers. But on the praxis, more likely than not, you are not going to be able to brute force it just by adding the terms together or multiplying 32 by 2 to get 64. It's going to ask you for like the 20th term or some for the first 30. So we can erase that then. There's another instance of a geometric sequence. This is an infinite geometric sum, and it is only if the absolute value of r is less than 1. So in other words, it's a fraction, right? It's going to be like 1/2, 1/4, negative 1/2, and negative 1/4, anything along those lines being multiplied each time. So, with that being said, it is going to be the sum up to infinity for the term number is equal to A1 over 1 minus R. So let's find the common ratio. 1/2 divided by 1 is just 1/2. And just like before, we have to take it again to be sure. 1/4 divided by 1/2 is going to be 2/4. And that will end up being 1/2. So we found our R value then is 1/2. And we can plug this all in. As the sum, actually I'll do it up here so you can all see, as the sum of infinity, we will get 1 over 1 minus 1/2 is going to be 1/2. So we will get this. 1 is the same as 1 over 1. 1/2 obviously is 1/2. And we move this to the top, so we get 1 over 1 times 2 over 1. Multiply across 2 over 1, which equals 2. Now, obviously we can't brute force this one because we're talking about infinity. But what we can do is we can see what we're approaching. 1 plus 0.5. We get 1.5 plus 0.25 plus 1 over 8. And we see that we're getting consistently closer and closer and closer to 2. So we see that this works out. Just remember that the R, or rather the absolute value of R, is less than 1. Lastly, we have our quadratic sequence, and remember that really we just need to be able to identify this. Yes, we could figure it out, but you're not going to be asked that. I've only seen this asked on the practice maybe once or twice, and neither of those times were they asking for like a summation or for a certain term. But, so let's take a look at this quadratic sequence. We're going to take this difference. So 20 minus 15, or 20 minus 5, sorry, is 15. 45 minus 20 is 25. And the difference between 80 and 45 is 35. So right there, that doesn't seem to tell us much. But we got to remember, when we're talking about a quadratic, it's not the first difference that we're really concerned with. It's the second difference. If the second difference is the same, then we have a quadratic. So 25 minus 15 is 10, and 35 minus 25 is 10. So we have that consistency. And with that, that should do it for sequences. Thank you.